So thanks, everybody. This is just a follow-on, actually, from a presentation I did last year, I believe, where we just started investigating this linking of AI and where we've got to and what we've learned. So we have a platform for digital twins called Fusion Gemini. So when you hear that name, it's not the Gemini Call or any of the other Geminis. It's the software that we use. And as a digital twin, the way that we look at this is that we are completely agnostic of everything. So we ship with a taxonomy, but it can be blank and you can start from scratch. So what that means is that when you see what we're presenting, it's completely customizable to your industry or to your needs. The way that we use a digital twin, we look at it for being able to digitize anything, to be able to automate and react to tasks and to events. We integrate with data, either exporting it or importing it. We use it to analyze and report, and use it to visualize. And then the final part of it, we integrate with other systems, such as raising a ticket if there's an issue on site or issuing an invoice and so on. And we also export parts of the model to other formats and systems in different ways, which is where the AI integration came about. Terminology for what we use, we're quite low level, so we think of everything as being an entity. And a chair is an entity, a building, an idea, a note. It's all an entity, and it has a type. We also then have relationships, which are totally customizable. So we can attach things together. Default is a hierarchy, but you can also have relationships such as was seen by or passed by or was scanned at, so on. The entity types that I mentioned, we have a hierarchical taxonomy, which means we inherit from below. So we could define equipment and then a meter and an electricity meter, and we could class an electricity meter as either a meter or a piece of equipment. So it's that kind of a taxonomy. And the resulting ontology, I guess, or model we would call it, is these entities and the relationships. So entities and edges in pure sort of graphs. We've also got time series data, which we can bring in, and we've got a huge sort of amount of APIs for managing data from all sorts of different things. And then finally spatial, which we're not going to cover today. So at the moment we've got existing outputs, but it's all developed within the platform. We have a development tool built in and so on. So it's quite easy to do, but customers are not able to do it. They have to come with a request and they have to ask, could you please generate us a report for this? Or if they've got their own development team, they can build it themselves. But we were looking for something where they would be able to actually look at the data themselves, look at their own model, understand their business, and start asking it questions. Fire away. So this is our mission for it, was to allow users to explore models and answer questions, discover and innovate, and to generate content to speed up reporting, which is the most common use of our twin. Look at everything over the last couple of years, bring it out and put it in a Word document or an Excel spreadsheet and so on. So we went about this by making sure that our taxonomy had an understanding for AI. So we've added the ability to describe to the AI semantically what each type of entity is. So you see here, for example, we've got an animal and it's got a description of what an animal means in our model. It could be different in a different model. We've then got this hierarchical taxonomy. So we've said we've also got a cat. So now we can start to differentiate on types. So a cat is still a living organism that feeds on organic matter, etc., but it's also a small domesticated carnivorous mammal. So we can ask the AI now about these things. And it actually says later on it eats small rodents and things, which is why I've got the risks of cat and mouse there. This is what we end up with the relationships. We have a network graph, which is a very good way of being able to sort of navigate around and react to different configurations. And the relationships that I mentioned as well, we support temporal relationships, which means you can have the same relationship multiple times between entities, but with different timestamps, which is very useful for things like visits or, again, scanning things or something passing by something else. So I'm rushing through this because I haven't got very much time and it's quite complex. I want to show you the actual thing. So the approach that we took was, at the beginning, there was no ChatGPT. There was no service that you could log on to. There was no memory, so we had to self-host. So we did this with AWS, and we were using Claude, Anthropic Claude, and it was very expensive, and it was very, very difficult to set up. It took us quite a while to get it working. But nowadays, forget all of that. You can just go on to quite a lot of different providers, and you can get access via APIs, via instances, which is very useful for us because we have one model which might map 50 different customers. So there's a security level where they can only see entities that are relevant to their business and so on, which we need to be able to handle in the AI, which we're able to do now. So the first approach that we looked at was just dumping a model semantically into a document and then letting an AI read the document and then answer questions, which worked really well. The issue that we had is it opens up room for interpretation because it's not structured data. If the lexical semantics are slightly ambiguous, it can start to make interpretation. So for lots of models, it'd be perfectly fine. Some models it won't be when there's notes and things coming in from customers, for example. The second approach we took was just going straight to the data source of the Fusion Gemini software using an AI tool. So we did this with Microsoft and Amazon. So going with Power BI, for example, but our data structures are too complicated for it to just connect to. And it doesn't have the semantic understanding of what's going on built in. It just goes to the data. So it doesn't sort of extract that semantics over the top. So it works really well for some things, not so much for others. But a good way of doing this could be to build, like I said, an external version of the model and then bring it in to these sorts of tools. It would work fine. And then final one we did was a combination of the two. So we extract models and information out as structured data, JSON files, to the AI. But then we also present documentation with the lexical semantics, what things are, what is a type, what's a relationship, etc. And then we're able to start getting much better results out of the AI. So I'll switch very quickly to ChatGPT. So after importing the data, and the data that I imported is here. So, for example, these are the entities, 2 buildings, 2 meters, just for energy. I thought it was relevant for the next presentation. Some information about some data, some information about some site reports that have been given, and then the relationships between those entities. So by putting all of that in, ChatGPT starts to understand what's there. So the end result is it's extracted these entities out. And then what I can start to do is I can start to ask it questions. So I've not told it what anything is. I've just dumped these files into it. How much gas did the headquarters building use? So now it starts to understand how it's extracted things out. And you can see the workings of where it got the data from for doing this, for making sure things are right. I've then asked it to convert from cubic meters to kilowatt hours. So it tells me that it doesn't have the information. That's what it's actually saying there. It needs a calorific value of the gas. But it's saying, would you like it to be on a specific one, or would it like to be the standard? So I've just said, just use the standard, and it answers the question. Then I've gone to generative. So I've said, could you please write me the paragraph outlining how much was used across 2023 and 2024? And it's dumped that out in cubic meters. So this is very, very good for a lot of customers because they will copy and paste this in for reports, their annual, especially facilities management, things like that. Then what I've done is I've looked here. I started off by just asking it whether there was any weird ones where there was 0 usage, and it's brought it up. And then what I did is I uploaded the site information from an engineer, which had talked about an unrelated issue. It's nothing to do with the meter, but it was something weird that happened on the site where there was a bypass that had been installed, and then it was fixed. And after doing that, it starts to understand that there's actually been something that's taken place. You can see here on the 30th of August, it was corrected. On the 19th of July, it's happened, and it's put the relationship between the two. So it recorded 0, aligning with the report that gas was bypassing the meter. So that's the benefit of the large language models in the AI. And then just conscious for this, very, very useful estimations. So by taking the historic data that we've got, I can ask it to start to project how much consumption we're going to have and to create documentation on that. And again, just very small prompts that I'm using, but I'm generating something I can copy and paste, and I can see the workings of, more importantly, to just validate it's all right. And then this is one that's come up now that we're just working on. We were going to have to code this, but it's answered the question for me, actually, by doing this demo, which was we want to be able to work out kilojoules per 100 cubic meters of volume of building. So by giving a building a volume, which is when I've uploaded it, and the values in the meter, I'm able to ask it to just generate that data for me. And it's told me how it's calculated it, and then given me the results there. So hopefully that's just a quick overview of it. And yeah, any questions I'm happy to answer.
So first question, highest rated question for Ben. How accurate are the reports from a generative AI model, given it tends to give probabilistic responses? How are you checking for accuracy?
Yeah, it's a very good question. So that was the reason for that third approach. So by giving structured data, and if you know AI, you can prompt about how it interacts. So you could say, for example, don't use any data values that are outside of the supplied data sets for calculations. So, you know, by honing in where it's allowed to bring data from, you can get that. And as I showed you in the demonstration, you'll see it in ChatGPT especially, you can show the workings. So you can then start to actually just verify that what you're getting is accurate. But yeah, it's always a thing, but so far it has been 100% accurate for, you know, reading the data in this structured way. It doesn't hallucinate or you know, try and bring in a figure from somewhere else.
Ben, what differences have you found? You mentioned a few different, you know, you were trying Claude and you were using ChatGPT. What are the differences you found between the AI models? As a sort of, I'm afraid I'm going to have to ask you for a quick fire answer.
Yeah, really quick. So I would say for most people, this is geared at a customer. So ChatGPT gives you a brilliant front end where they can use it and gives you the workings like I've explained there as well. Claude and things, when you start putting them in, they're probably a bit more techy. But otherwise the output's pretty much similar.